Okay. So, as I said, I've been asked to say a few words about ventilative cooling in the Belgian method to calculate cooling loads, because this method is going to change in the coming months. Well, in fact, we have a temperate climate, so cooling is not much a problem here in Belgium regarding heating loads, for example. Until recently, when authorities decided to straighten cooling demands and more specifically set a maximum cooling need of 15 kilowatt-hours per square meter per year in offices and schools. So it's quite severe as a requirement, and field architects, engineers were worried about the feasibility of this level and the way to improve the cooling calculation method to allow them to really show the quality of their design, because basically key strategies such as ventilative cooling were not included in the calculation method. So the actual method that is going to change is that one, which is quite simple. It's a monthly balance. You have gains, losses, obviously utilization factor. Regarding losses, we only consider ventilation losses linked to air quality and uncontrolled infiltration, so nothing about night cooling, free cooling strategies. There are two factors that multiply this balance. 1.1 factor, which is a conventional factor aiming at representing the condensation on the surface of the cooling devices, so the humidification in the space. Another factor, which is a probability that the cooling system, an active cooling system, will be set in the building. This is based on a calculation of the excess energy, and basically in most cases it's 1 or close to 1. So the questions about this method is there's no place for intermittence, although there is a calculation of intermittence for cooling loads in Belgium, so why not for cooling loads? What's the pertinence of this conventional 1.1 factor? What about the probability factor? Is it really necessary to go through this calculation? What about temperature hypothesis? I'll go further on that later. And what about ventilative cooling, obviously, which is the point today. So the modified method that is now going to be implemented in the coming months and be mandatory in 1 year or so. We have a distinction between gross cooling needs and net cooling needs, and the conventional factor that is aimed to represent dehumidification is now considered at the level of the gross cooling need, while the 15 kilowatt-hours per square meter requirement, it will be checked at the level of the net cooling need. So this 10% malus will not be considered anymore regarding that specific criterion. Another change is the introduction of an intermittence factor, which is based on ISO 13790, as most of other European countries do. So there's nothing really new about that. And the biggest point that will change is about the calculation of losses, and especially ventilative losses. We now have a distinction between various terms, one for hygienic air quality ventilation, one for infiltration and exfiltration, so uncontrolled ventilation, two for additional mechanical ventilation, 1 day, 1 night, and two for natural intensive ventilation, day and night. So we have a quite comprehensive framework now for all kind of ventilation that can be set in the building, either natural or mechanical, and either day or night, or continuous, such as infiltrations. Another quite major change is about temperature hypothesis, and you see that, of course, obviously you have indoor temperature and outdoor temperature. For outdoor temperature, you have a term that is the mean climatic value. Another term, which is a correction intended to include the fact that last decade's summer are quite hotter than previously known climatic files. So we have a factor that is basically around 1.5 degrees regarding various months. And a third term sometimes that's a correction term intended to have a monthly mean temperature that is dedicated to day hours or night hours. So to go a little bit into numbers, you have in this table the mean monthly temperature, and so for example in July it's nearly 18 degrees. It will be turned into 19.3 degrees in days and 15.4 degrees in night. This is quite important to be able to consider nighttime ventilation, because you see the temperature change, the temperature difference between indoor and outdoor will shift from something which is like 25 minus 18, let's say 7 degrees, to something which is more close down, nearly 10 degrees. So it's 30% more impact for the nighttime ventilation than before, just by changing this hypothesis of outdoor temperature. We will also adapt indoor temperature. In fact, now designers will have to set an hypothesis if either there is active cooling or not, and if not, do they design their building in accordance to adaptive criterions and adaptive comfort strategies. And we are based for that on the European norm 15251 and the Annex 1 of that norm that says the conditions to consider free float and adaptive comfort theories. So basically, once again in July, a building that is equipped with fully air conditioning system will be calculated on the basis of 25 degrees. But if you do not have air conditioning, only natural strategies, the calculation of the cooling needs will be done on the basis of nearly 27 degrees. So once again, it's quite an important change regarding the small temperature gaps we have between inside and outside during summer months in Belgium. To go a little bit deeper in the way we will calculate airflows and ventilative cooling, we have in that term, which is dedicated to natural ventilation at daytime, so intensive natural ventilation, not IAQ. We have a calculation which is based on a conventional airflow, which is around 73 cubic meters per square hour and per hour. This is an estimation of what we can have with a medium temperature difference between inside and outside for a single side in ventilation and a window-shaped opening. So this is a conventional value. You cannot change that in your design. So there's no way right now to take into consideration cross ventilation, for example. That's not yet included because of the uncertainty of pressure coefficients on the building. We do not have something which is quite consistent enough to go to regulation at that time. Some factors, obviously, to take into consideration the fraction of time, of how much time will this ventilation be used. It's a function of the gain-loss coefficient. It's something we also have in ISO norms. Nothing very specific about that. And a correction factor to consider hypothesis differences between the hypothesis we made in this static calculation and the dynamic simulations we do to evaluate coefficients such as the fraction of time. In fact, the correlation between the fraction of time and the gain-loss coefficient is set based on the large sets of dynamic simulations, and there are some hypothesis discrepancies between the work done for those simulations and the hypothesis of the static calculation. So this coefficient is there to take that into account. And something which is quite maybe to be discussed is that authorities have considered that when you have an opening window with an extra ventilation, you should not take into account anymore the infiltrations. So we'll reduce the potential of opening windows by the airflow linked with infiltration. This is not a major point since building now in new buildings now are quite airtight in Belgium. There are specific regulations regarding that, so it's quite a small amount of air, but yet this consistency might be discussed. For forced airflows, well, basically it's the same idea. You have a fraction of time, you have airflow. What's specific is that this airflow will be measured in situ. So the designer cannot make an assumption. He cannot just say, yeah, I will have so much air. He has to prove it. So it will be in situ measurements linked with measurements of the fan energy consumptions. I will go back on this just after. But basically, if the designers are not able to prove of a real airflow, the default values will be set equals to the hygienic ventilations. So since here also you see we have a difference there, the airflow for intensive ventilation, and we will deduce the airflow for hygienic ventilations in order to have a term that only counts for extra ventilation, additional ventilations above air quality level. If this value is set equals to the hygienic ventilation, of course the difference will be 0 and there will be no impact. We have some coefficients to correct this difference. This one is just like for natural ventilation, and we have coefficients dedicated to take into account pre-cooling strategies such as air hurts, heat exchangers, or adiabatic coolings, or things like that. Regarding fans consumption, that's obviously, if we consider extra mechanical ventilation, we have to take into account also the impact on the fan electricity consumptions. So the term about fans is now divided into 3 terms, 1 for hygienic ventilations and 2 for additional ventilations for day and for night. You have the details. I don't have time to go too deep into that, but the basic idea is that the designers will have to prove the installed power, and we have a correction dedicated to consider the fact that there is a modulation, and not all this power will be used basically for hygienic ventilation. We just have a fraction of this. While when you have an additional high airflow ventilation, this value will be 1. Once again, this difference is there to have a term that only counts for the additional electricity consumptions above the IAQ1. So about the impact of all those changes, in this figure you have the cooling need for a set of building. I don't describe the sets, not very consistent. There is just a large set of typical office buildings with various kind of skins, various kind of shading coefficients and thermal mass. And we have quite a large panel. What we see when we make the changes regarding temperatures, outside temperatures, indoor temperatures, and intermittence, we have quite a large impact, and that's one part of our job. And when we go further and add either mechanical intensive ventilation or natural intensive ventilations, we still go further in the lowering of the cooling loads, cooling needs, but it's much less consistent, but much less important than the changes we've made on basic hypotheses such as temperature and intermittence. So as a conclusion to this, only few words, we will now have, hopefully, end of 2016, comprehensive framework for ventilative cooling, but it is still limited in the impact due to conservative hypotheses, basically on airflows and fraction of time of use. Other changes we've made are more sensible. And what we said to the authorities here is that we could go further into considering the impact of intensive ventilation, ventilative cooling, but we should have a stronger field of knowledge regarding basically how people act regarding window opening, or people act regarding mechanical airflows. And the key factor regarding that is what fraction of time will those strategies be used. And this is not easy to determine in order to be representative of a really average behavior, because we're not intending here to describe very specific cases, specific buildings, but a large-scale kind of behavior. So we don't have enough field studies about that, so that's what we said to the authorities. Hopefully they will fund some research about that. But further, before trying to calculate more precisely fraction of time of use, for example, on a monthly basis, there's a key question that should be asked: is this consistency of having a monthly calculation rather than an hourly one regarding cooling, because you all know, I guess, the impact of thermal mass and the impact of the dynamic response of the building for cooling loads is very, very important, much more important in our climate than for heating, for example. Basically, in heating, it's always cold, and just have a little bit of sun to reduce your losses. But for cooling, you're in a steep equilibrium between heats and between gains and losses. So the dynamic response really is a key factor, and having a monthly based calculation balance is not very accurate. And that's it. Thank you for listening, and I'm waiting for your answers.